I'm going to walk you through, and then I'm going to have you kind of struggle on your own, and we'll talk. But let me give you the document to go off of. So you guys are going to do a lot of programming today, which will be fun. And we'll talk about, let me put the document out here. So this is the document. So, and then I should be able to share my screen. But I'm going to ask you guys to actually, I find it easier if instead of me sharing my screen and you guys trying to keep up, I find it easier when I put another student's screen up, because then they go the speed that's good that everybody else goes at. Either I'm too fast or I'm too slow, but I'll put up my screen at the beginning. So let me get this up here.
Maybe Damien would be our demo person for us. Damien's a brave soul. I know that.
Okay, good. We'll put Damien. We'll let Damien share screen.
All right. Volunteer for things.
So I actually have two quotes up here. One is, I like the first one just because I think it's good for students. And it's, learning requires failure, blah, blah, blah. And especially getting the syntax. There's going to be two pieces today. One is the syntax of working with NumPy. And the other one's the conceptual piece of working with NumPy and seeing, because you really have to visualize what it's doing, because it's always, God, we always joke around here. It's always one line of code, right? We don't do, and then the second quote was, you must unlearn what you have learned. My kids start writing for loops and I say, stop, we don't do for loops, no loops anymore. They'll do nested loops. Why are you doing a nested loop? We don't do that because it's actually inefficient with NumPy, and NumPy just handles stuff. It's crazy. And if you're really familiar with NumPy, then you'll know that. But if you're not, you need to unlearn all your for loop stuff. So at the very beginning of today, I'm actually going to show you how it's done with for loops, nested for loops with lists in Python. And then I'm going to show you, in one line of code, what NumPy does. It's going to be crazy. So there's definitely going to be a shift, a paradigm shift for you. And it takes a little while. And then once you kind of get into it, it's actually kind of fun. We're going to use Colab notebooks. We're going to walk through this one. That's probably going to take, we'll see how long it takes. I'm thinking it's probably going to take 30, 40 minutes. I have no idea because I've never gone through it with teachers before with Python experience. And then we're going to do some plotting of data as well. So we're going to manipulate data, a lot of matrix stuff, because, and I geared this specifically towards, this is Python for machine learning, and Python for machine learning is all about matrices, and it's all about 2D matrices. And then we're going to use NumPy to do all of that 2D matrix manipulation. And today is really, the whole purpose of today is to give you, so there's so much more. I can't do it all in an hour. Today is, hey, this is some cool, neat stuff. Here's kind of an introduction into the paradigm shift. And here's an introduction to NumPy and graphing. And that is it. This isn't to make you, an expert in Python. This isn't to, do gradient, to teach you how to do gradient descent with NumPy. It's none of that. It's basically just to introduce you to the concept of NumPy, matrix math, and then some simple, hopefully, simple data visualization with Matplotlib. Cool? All right. So I'm gonna stop screen sharing, and Damien, I'm gonna have you screen share, and I'm gonna walk you through, hopefully, so if you can screen share, I'll walk you through it. I don't know how Colab Notebooks comes up, but click on that Colab Notebook NumPy. Hopefully it'll make you come up and just log in. You have a Google Drive, you have a Google login, I'm assuming.
Yeah. And
just use that. And the nice thing about Colab Notebooks is it's Jupyter Notebooks, which runs, it'll run Python on Google servers, which is great, right? Is it coming up? Is it not coming up? It's loading.
Maybe coming up slowly. Yeah, there it is.
There it is. Okay, great. So do file and then save as, so you can make your own copy. Make a copy, so because it's not going to let you. Yeah. Save a copy. Why don't you save a copy and drive? Yeah, save a copy and drive right there. You got it. Yep. See, this is why I walk people through it, because you wouldn't see any of this with mine. All right, so now you have your own copy on Google Drive. And if you go to Colab Notebooks, it'll have your previous copy like in your own folder, which is cool. And we'll just wait for this to come up. All right. So if you click on the NumPy cheat sheet, it's all about cheat sheets. And I don't know, I'm not sure if we want to do half screen and not. I think at the beginning we won't. I want you to know that this is out there though. So almost everything we're doing today is on the sheet, okay? Plus. And there's going to be some stuff I'm going to ask you. And is Nita still here, right? And Nita, did I say your name right, Nita? Hopefully I did.
Hi, it's Netta.
Netta, okay, sorry, thank you. I would have called you by the wrong name the whole class. All right, Netta. I am going to ask you guys to kind of figure some stuff out on your own, because what happens is there's just too much out there. And a lot of, usually like our kids that we teach machine learning to, they're post APCS. In APCS, a lot of that is kind of spoon feeding, right? But then there becomes a point where they need to start looking out, and we do, and I'm sure you guys do it too, but you have them kind of look up libraries a little bit, but there's so much stuff to cover. You're like, here's an array list. Here's a method. Here's the 7 methods or 5 methods you want to use with array lists, and just, stay in your lane with that. And maybe you have some super smart kids that learn some of the other methods, but you really don't teach them that. This is different. There's so much out there. You can't teach them everything. So one of the skills we teach them is to go out and find out and it's changing so much. So some of the stuff that, like, I had some of my programs from 2 years ago, and the methods that they use now are changed and they're more efficient and they're cleaner. And so you're constantly having to go and stay up to date. You're constantly having to go look online to the documentation to figure out what you're supposed to do. So that's actually a skill that we teach our kids. And it's going to be a skill. If you teach machine learning and you teach Python for machine learning, you're going to have to teach them how to learn on their own. So one of the easy ways to do it is a cheat sheet. So they actually don't have to go to the NumPy documentation. So we give them that, but we also have them go and do, the Google searches and go to the NumPy documentation about stuff. All right, so go back to your Google. You're a man after my own heart with all those tabs, man. I love all the tabs.
That's just one of the windows.
Oh, I love it, man. I'm the same way until you're like, your whole machine grinds to a halt and you're like, oh yeah, I guess I better close some of these.
This is my laptop. The laptop's like, 5 years old or something like that.
So do Control+ a couple times. I think that should make it bigger with Colab Notebooks. If you just kind of click in that window,
okay,
and do Control+. Did it make it bigger? Yeah, there you go. All right, that's good. Now scroll down a little bit. Okay. Oh no, just so that first thing. Yeah. So let's look at this. So this is, if you're familiar with Java and familiar with NumPy, this is a way to create a 2D array of random numbers between 0 and 9, random integers. So there's got to be a way to look at the line numbers. Hold on. Let me see. Let's see. Well, anyway, go down that line where it says call.append. And it says int random. So that's your typical create a random number between 0 and 10. And right, and it appends it to the column. So that's the row basically. So it's going to create this 2D array, and it's a Python list. So this is not a NumPy matrix, and there's a difference. Now, the code below it will convert that list, which is called ARR, array. That'll convert it. If you look down in the last 2 lines in that section, that converts it to a NumPy matrix. And scroll up to the top a little bit, sorry. Yeah, just go up a little bit. See where you're importing? So every time you say NP, every time you say NP on that second line where it says import NumPy is NP.
Right, that just
Every time you say NP dot, that's going to reference the NumPy library. It's just a little shorthand, so we don't have to say NumPy. And if you say random, that'll do the random class. Okay, and for NumPy, which is cool. All right, so go ahead and run it. And if you click that arrow in the upper left-hand corner, that'll run it. And you guys know that Python is a scripting language, so it doesn't have to compile, and it'll run it, and it should give you the output down at the bottom. So maybe you need to do control minus once so we can see everything. There you go. All right, so that's the difference between a list and a NumPy matrix. And you can see it's two-dimensional. And what was the range? The range, so it's a 20 by 2, so 20 rows, 2 columns, and it's a bunch of random numbers between 0 and 9, which is great. But we don't want to do lists because lists are slow. And NumPy is specifically, it does matrix multiplication and it does it really fast. So scroll down some. And most of the time, now, if we want to do all that code, all you have to do is copy and paste that little x equals right there. And then run it. Yeah, see where it says x equals? Not that, yeah, yep. Copy and paste that and then run that little thing. And it should give you, I'm hoping, should give you the same thing. Rocks. Okay, so this is another, so this is awesome, right? And if you're thinking, NumPy's got to have this thing that creates, you know, an array of any size I want to give it with a bunch of zeros, it does. It's actually called np.zeros. So if there's things you think it should have, all you have to do is kind of say, how do I create a NumPy array of zeros? And go out on the online and there's a method probably already written for it. All right, so scroll down some. What time we got? It's 4:17. All right. So nested for loops generally go away. Python lists, don't use them, just say no. And it all becomes one line of code. So go ahead and run this next bit. So run that. That's going to take that other list and it's going to multiply the first column by 20. All right, so that's what it did. But we don't want a for loop. I hate for loops. So let's figure out how to do it. So scroll down some. Let's figure out how to do it with X. So now here's the tricky part. This is the fun stuff. All right, so if you type in X bracket colon on that next line, yep, X, open bracket, just like it says up there. When you say colon, that take all the rows. And then you do comma and take the zeroth column, the 0 column. So I'm going to take all the rows and the 0th column. Now, if you just put star equals, or you can say, do star 20 and say X equals, put X equals on the left-hand side and do that star 20. That's probably, you can do star equals works, but don't do that. Do star 20 right there. Yep. Yep, and then say X equals that on the left-hand side. Now this is going to do scalar multiplication on the first column. Now run it. We don't do for loops. We don't do for loops. All right, and that gave you the first column too. It selected the first column. Now if you do X star equals, you do that, and you do, that's fine. Just leave it like that. But so that's kind of cool, right? I think it's kind of cool.
John, can you give just like a little context as far as, you know, the matrix manipulation that you're doing and where that's fitting into what lessons the kids are working on when they're learning how to manipulate the numbers like this?
Yeah. Yes, I can, as a matter of fact. So one of the things that happens, the last lesson we did housing data. So we had square feet, we had number of bedrooms, and we had number of bathrooms. And square feet can be something like 2,500, 3,100, 1,500, right? 1,000. The number of bedrooms is like 1, 2, 3. I don't know. It probably doesn't match actually. 3, 2, 1. Number of bathrooms. It's probably right. 1, 3, 2, and 2, right? These numbers are really different. And when you start trying to find weights, I don't know, the one thing we talked about was we actually create these algebraic equation, which is you have like weight, this weight times plus, and then another weight down here. And then you want to predict the price. I don't know, say it's $300,000. And the whole goal of linear regression and even logistic regression and even neural networks is to find weights that will predict, given all this data, the price. And we did that last time. And it makes a lot of sense. Like if you were actually going to do it yourself, you probably start saying, well, what can I multiply by 2,500 in bedrooms and bathrooms? What are the weights of how important are each one of these features? And that's what we call them, was features. And what happens is if these numbers are really different, like the 2,500, the 2, and the 1, if they're really different, sometimes you get it really different. Like this might be 1 million and this might be 1.5 for whatever reason. Like it might be, yeah. So you might be way off. Then these weights become really different. And it really takes a long time for it to actually, when you go through and you do your gradient descent, it takes a long time to find these weights because these initial numbers are different. So what happens is you end up having to try to make these numbers really similar. And what you do is you scale them. So, and one of the ways you scale them, and that's actually the last thing that we do today, is it's called standardization, but you basically find the z-score of each one of these values. And you use the mean of the whole column to find the z-score. But you have to, higher level thing is you have to adjust these numbers so they're similar in size.
That's great. That's such a nice segue from the last session.
Numbers are similar in size, then it takes forever to converge. Mm-hmm. So you end up having to do basically kind of what we're doing. So you're going to have to find the standardized. You have, I don't know how much you guys know about standard finding the z-score, but it's you subtract the mean and you divide by the standard deviation of each column. So, and the math we're doing now basically lets you do this. So, and it's really important. If you don't do it, then it doesn't work. So there's believe me, there's lots of other things that you end up having to do, but you have to do a lot of math. Some of it's scalar math. Is that okay?
That's perfect. Yeah, that's exactly the problem that we ran into last time, that people saw the numbers were so different and they were trying to weight things. And of course, if you started out with numbers that were more balanced, you would be at a better starting place, and multiplying everything in a certain column is a great way to do it.
And basically everything like in this, you basically almost have, I mean, I created this NumPy example thing because it gives you almost everything like you need for machine learning. So the stuff I picked in here, I didn't just randomly pick it. I picked it because you end up having to use it. All right, so go ahead and run the next one, right? So it's gonna multiply all the rows and the second column by 20. All right, that's fine. Scroll down. We're gonna do this on our own, except we're gonna use, no, it's the one above it. Yeah, no. There was an empty, yeah, that empty one. So I don't know if, it doesn't really matter. We can do this. You can take that previous matrix if you want. So what we want to do, or you can take, I think X should be Yeah, try X. Let's print X first and let's see what X looks like. Just do a print X.
So right here?
Yeah, I don't think X, because I think we chose the first, and that's fine. And run it. I think it's a one-dimensional array when we last did it. Okay, so scroll up, let's recreate X as a two-dimensional array. And we'll.
Up further?
Yeah, scroll up. There you go. Yep, keep going. Let's recreate it. Remember when you created it to begin with, there was like one line of code. Scroll up. Yeah, right there. That one line of random int, scroll down. Yeah, this is what, yeah, right there, number 2. Take that. So let's recreate X. We know it's going to be a two-dimensional array, and then I'll show you, we're just going to take it, and we're going to take the second column and multiply it by 20, but let's do it a little differently. Go ahead, hit paste.
Yeah.
Now let's do, yeah, go ahead, you can run it, that's fine. All right, so now let's go ahead and change the second column. So come down below print X, or you can do it before the print X, because that way we'll print it after that. Yeah, there you go. So we want to take all rows, so X, open bracket, and then all rows is the colon, comma, and we want the second column, which would be 1, and then you can do star equals 20, and it should work. There you go. Okay, which is great. All right. So now let's find the minimum of a column. I love this. This is just like crazy, right? And the whole purpose of this beginning thing is hopefully getting you out of the old for loop stuff. So scroll down to the next input where it says run the code below, find the input. Yeah, run that. That's going to find the minimum. This is, classic. And the minimum was 0, which is fine. Now, we're going to use NumPy to do it. And this is, do I have it? All right, so we're going to find the minimum of column 0. So let's print, right? And then how do you select column 0 from X? All rows, column 0. So it's X, open bracket, all rows, which is, yep, comma 0. Yep. Now, instead, what you want to do is np.min, and you give it that. So you're going to call np.min, and you're going to give it X all rows 0. So you put that into the, yeah, so do np.min. Yep. There you go. I think that'll work. Run it. Another bracket, another parentheses.
Oh, yeah, print.
Perfect. You're doing awesome. Hopefully, as I'm talking through this, and that's the other big thing with Python and NumPy is, like, you'll get used to just converting the syntax in your head, right? You're not going to do X bracket colon. You're going to think X, all rows of X in the first column. That's the way you're going to read that. All right, so scroll down some.
How do you read the square bracket notation? Everything before the comment refers to the rows and everything after the comment refers to the columns?
Yes.
So it's like X, Y.
Yes.
Okay.
So if you wanted to do, you know, 0, like you could have done 0 colon 2.
And you would just do the first 3 rows that way.
No, well, if you'd done 0 colon 2, would have given you, instead of 0, it would have given you the first 2 columns.
Oh, so it's exclusive of the second?
Yeah, it's just like with Java and everything else. Yep. Okay. So yeah, and that's called slicing, and I'm gonna show you. Yeah, so if you've done that, well, we give you the first 2 columns.
Okay, gotcha.
Cool. All right. So scroll down. So that's just like in Python and Java. All right. All right. So we can. So you just found the minimum of. You just found. Erase this stuff. You just found the minimum of 1 column. I can actually create a whole matrix of minimum values, which this is when it starts getting crazy. Actually really cool. So I can, if I do np.min and I tell it axis equals 0, I don't know if you can see this, hopefully you can. Yeah, if I give it axis equals 0, that means find the minimum, the average, the standard deviation, whatever, do it down. And if I say axis equals 0, axis equals 1, that means do it across the rows. And the best way to see it is just that. I love that diagram. So let's do that. This is really cool too. So come on down to the next one and do, no, you had it. You had it. We're going to type this in live right above call 1 max. We're going to create a new variable called call1. And you're going to set it equal to np.min. And then do the column 1 again. I think we do the average of all the columns next. So we're going to do, yeah.
Max is going to be min. Oh, boy, you are.
Sorry, do max. You're right. You're right. Thank you. Sorry, I was looking. There you go. Now give it the same thing you gave it before and then do the same thing with min.
So we're doing the X.
X colon all rows, column 1. Yep.
And run it?
Oh, might as well do the next one too. We're about to get to the more fun stuff. Hopefully this is starting to become a little boring. Call 1 max and then do we do call 0? Do call 0 min.
Is the actual variable name call1 underscore max that you're printing?
Yeah, so instead of call 1, it's call 1. See where I'm printing it down and below it?
Yeah, because Damien renamed it on the second one.
Yeah. No, you're good. Yeah. Call 1 min, and then you need to do call 1 underscore max.
This needs to be max?
Yep.
Minimum of column 0?
Yeah.
You start to get the feeling you have a little power over the numbers. I can manipulate you numbers wherever.
Oh, I know. It's crazy. It is. It's the one bad thing I don't like about Colab notebooks, and I'll show you what it looks like in Spider because I love Spider. Spider has an amazing variable explorer, so you never have to print out anything. It's before we end. I'll definitely show you that. Run it. Okay, cool. So let's scroll down and let's get a whole matrix of these values. So instead of doing them individually, and guess what you do? All right, so we're going to do the average of the first column, and we're going to set our axis equal to 0. So let's see, what do our variable names call 0 underscore average? And we're going to set that equal to np dot mean. You can do average, but you do, yeah. And then open. And then give it x, comma. Give it the array you want to do it. And then comma axis equals 0, which means you want to do, no, just say x. You don't have to, no, just say x. Just give it x. Yeah, comma. This is why it's cool. Comma, and then axis equals 0. That says do the mean down. All right, so this actually will do, I said to do the average of the first column, but this will do everything. So go ahead and run it. Oh, it's going to give you an error because we didn't do the, sorry. You can just comment that out. Comment out that second print. My bad. Hash. Yeah. Perfect. You rock. There you go. So that is the average of the first column, 5.1, and 84 is the average of the second column. That's freaking cool.
Okay, so it just goes down.
All right, so the next thing that you need is the shape, the two-dimensional shape, and you can use dot shape will give you the size. So if you do, I don't know, you can create a new, let's create a new variable called dimx and just say equals x dot shape. And let's print it out and I'll show you it becomes a tuple under the, no, in the next one. Yeah, in the next, see where it says size right there, the next block. Yeah, there you go. Capital X dot shape, yeah. Now this is going to give you a tuple where the first element is the rows and the second element is the columns, so run it. So you can do dimx of 0 and that'll give you the rows and dimx of columns, that'll, yep. So it's a 20 by 2, which is great. And the reasons why it's great is like in machine learning, you need to create the number of weights that's equal to the number of columns. So that's like one of the very first things we do is we actually create this weight matrix and we use shape to do that. All right. So let's come down and come down to the next one. So another thing we need to do is create some empty matrices. And we're going to create a column of zeros, but we're going to make it the same number of rows that X is. So we're going to do np.zeros. Yep. And we're actually going to give it a second parentheses. And this happens go ahead, second parentheses, yeah. So how do I know the number of rows? It's dimx of 0. So if you do dimx and then do bracket 0 for the first element, that's the number of rows. And then do comma and then do 1. And that'll make it one column. All right, yep, run it. So now, so you took this and we want to add it on just for kicks, because sometimes you do want to add stuff and you want to be able to kind of, you may create a column and you may want to concatenate it onto something, right? You want to concatenate it vertically. So if we want to concatenate it vertically, just, it makes sense when they explain it, but it's called HStack because it concatenates the rows of the column. You would think that that like concatenates horizontally, right? But it doesn't. That's sticking a column side by side is H stack, and V stack is the other one. V stack does this. Just go with it. I think it's counterintuitive for me, but that's fine. So we're going to stick this column onto the right-hand side. So we're going to use H stack to do that. So come down to the next one, the next input, and we're going to concatenate A on the, so this gives you this actually shows you what H stack and V stack does. I took a couple good images and we're going to H stack that sucker. Okay. So let's create a new array. Do you want to call it X still? Let's call it X. We'll just change X. X equals np.hstack. And then two open parentheses, and then give it the arrays you want to stack in the order you want to stack them in. X, I think, is first, and then A, comma A. Yep. Now, a lot of people go, why are there two parentheses? And that's because sometimes there's more parameters. So that open paren X comma A close paren, that's one parameter, and H stack actually takes more parameters. So that's why there's two sets of parentheses. Just most of the time you don't use the other parameters. Okay. So run it, and it should throw those zeros on the right-hand side, I'm hoping. Bammo. Cool as crap. No for loops. Is that cool? Come on. You're supposed to be saying, dude, it's so freaking cool.
Freaking cool.
Thank you.
All
no
right.
for loops. All right. You can also do math. All right. So we want to add the values. So we have this third column that's 0. So we're going to add the values from column 0 and column 1, and we're going to put it into column 2.
Okay.
So select column 2, right? No, it's not the whole array. It's just column 2. So X, all rows, column 2. When I say column 2, I mean literally 0, 1, 2, right? Yeah, all rows.
Okay.
Which is colon, and then, yep, and then column, no, do column, you can just say column 2, because that's that third column that's zeros, right?
Yep.
And set it, and say equals. Now you should, and then just add them. Add column 0 and then add column 1.
So X.
You rock, dude.
Just out of curiosity, why would you pick a capital X as the name instead of a lowercase x?
Yeah, so sometimes what I do is for the kids, so they don't get confused in the method, I'll do lowercase x, and then when I'm out in the main part of the body, I'll do an uppercase X, so they don't get confused which is which. You can do all lowercase, but you know, sometimes they get, because they use X in the method, then they use X in the main, and they're not always the same, and then they get confused what's what, and blah, blah, blah. Bammo! No for loops. No frickin' for loops. I think it's cool. All right, we're almost down to the bottom. That's awesome. All right, we're almost down. We almost set you up for like the fun part. What time is it? 4:43. All right, we're good. Okay, so now you can slice rows if you want. So now slice some rows, because sometimes you have like header rows in a file and you may not want those header rows. Or you know, who knows? So now this is going to be different because you're going to be selecting rows and not columns.
Okay. Selecting rows and not columns. Oops.
Yep. Although that may be rows. Well, we'll see. Go for it.
Oh, yeah.
Doesn't really matter, right?
Could be 2,
I think you want, yeah, I think you want 2 and 5. There you go. And let's see if that's 3, 4, and 5. Scroll up a little bit. 0, 120, 120. 3, 4, 5. Yep, cool. You got it, man. You got it going on. Yay. Thank you, Joel. So what we're doing actually is called slicing, and it kind of makes sense, right? What you're doing is you're just picking the slices of the array that you want.
Yeah.
And NumPy is actually really efficient. It doesn't it depends. It gets a little tricky, and I don't want to get into the subtleties of it. But if you can imagine with huge matrices, it shouldn't be making copies. So a lot of times what it'll do is it'll just take views of a matrix. And if you have, sometimes we'll deal with data sets of 7 million rows and, 20 or 30 features. And when you're doing that, you don't want to be making copies of matrices. So NumPy is super efficient. And this is one of the reasons why we don't use lists. It's really good about, taking views of it and not copying, if that makes any sense. It handles all of that stuff.
When you do a slice, are you making a copy or are you picking?
No, it depends, but most of the time you're just doing, a view, which is cool.
Does anything like NumPy exist in Java, or is this kind of just like the cutting edge and that's why Python?
This is cutting edge stuff that's just been written for Python, yes.
So
and I would say this is why 8 years ago, Python was Matlab and things like that were used for machine learning. And then they created NumPy, and that's why Python has taken over. And I don't know why you wouldn't use NumPy.
So the only way in Java to do something like this would be going to your big no-nos of using lists.
Yeah, you wouldn't do this in Java. I mean, you could, but it wouldn't be, you'd really bog down when you actually started doing stuff. And it would take forever you would end up writing, the methods to do these helper methods to do all this crap.
Yeah.
But somebody else has already done it, which is great. All right. So you don't really, this is, if you want, you can concatenate arrays. And you just use HStack to do it. But how much time we got? 4:48. So let's scroll down and let's do the challenge. So one of the things I said was that you have to scale your data, right? And you can close, I actually ran it. I actually tested it and ran it. So you can go down a little, that output you can delete. If you want to leave it, you can. But this is actually going to be really easy. So let's go ahead and get so if you look at line 2, it says calculate a scaled matrix. So we're going to use the column average and the column standard deviation. So let's create temporary variables that are call average and call standard deviation. And you can, I think it's np.standard. Let me look, np.std. Yeah.
So X call average.
Yep. Equals. Now, if you want, this is kind of a new thing. You can say, because data is as a NumPy array, you can say data.mean if you want. It's a different kind of syntax, but you can say data.mean, and then you've got to give it the axis, remember? You got to tell it whether to go across the rows or down the columns. Axis equals 0.
And same thing for standard dev?
Yep. And let's print those out. Let's look and see what those look like.
I'm guessing. Cost.
STD.
STD?
Yep, that was a good guess though. Now, normally, like when I teach this with my kids, I do like the first 3 or 4, and then I put them in breakout rooms of 3 or 4, and then I say go, and you gotta find all of this on your own. And then put the close, yeah, and then go ahead and print those. Go ahead and print those.
Print just both?
Yep. And I actually wanna talk about this. Because this is a wild concept. It's super powerful. It's called broadcasting. One, 10, 11, 12. Actually, I didn't make this smaller.
These names have to be different.
What's does it not like it?
Change the variable names?
Yeah, can you do a dash? I like never use dashes. Yeah, just do. Try that. It's not going to print it out, but there you go. Yeah, that was the problem. Yeah, I've never used dashes. I was like, I don't think that works, but.
No, it doesn't. Yeah, that makes sense.
Okay, so were you able to print it out?
No, I think we have to rename these.
What's wrong with it?
I think isn't this up here where they're saying these? Aren't these the formulas that they're trying to get us to use?
No. And that's not they, it's me. I'm the one who wrote it. Okay, so then let's just do, that should work though. Run it again.
Let me finish.
And maybe it doesn't like the data.standard. We might have to use np.mean and give it data.
Okay.
So let's try that, see if it works. Yeah, okay, so let's do np.mean, give it data, comma, axis equals 0, because we know that works. And it works in my spider, and this is kind of a new format, so I'm wondering if Colab Notebooks doesn't let you do that. So do np.mean, data, comma, axis equals 0. Yeah, and do data, not date. And then fix that date above it. Yeah. There you go. Now run it. It should work.
It just doesn't like the print with the pluses. You're thinking Java. You want the commas in between things.
Oh, yeah. Sorry. No, you need commas. I didn't even catch that. I thought I'd given the print and I didn't. Yeah, do the commas. Thank you.
It's the problem with switching languages all the time.
Oh my God. Okay, so what happened was, right, we got this 2.5, 25, 26, and 17.5. But what we want to do is, I want to take this right here, right? And I want to take this row. So I'm going to want to take, what is my, I'm going to want to take 1 minus 25, 10 minus 25, 11 minus, right? I want to do this 1 minus 25 divided by whatever my standard deviation is for that first column, which is 1.11. But how do I take this? How do I take this whole matrix and just subtract this? They're not the same size. I can't do that, but I can. So what NumPy does is, it's called broadcasting. And if I try to take this matrix, right, which is data, and this matrix, which is average, and subtract it, it will say, they're not the same size. I think I know what you want to do. And I think what you want to do is this. I think you want this huge array here. And it broadcasts all of the values down. Whoops. And it'll make it a 4x4 so that when I do my scalar subtraction, when I do the scalar subtraction of average, it'll make this the same size, and it'll do it for that second array. So, believe it or not, you can actually just say, data equals data minus call average divided by standard, and it will do it. It is crazy.
It's only called AVG now.
You guys kind of get that?
You're
like, you're looking at it, you're going, it shouldn't do that. They're not the same size. You can't do scalar subtraction off of matrices that aren't the same size. Well, NumPy goes, oh, I know what you meant. And it can get crazy because what it'll do is, yeah, go ahead. And then you print out data when you're done. Broadcasting is super powerful. Bam. So now you have your standardized data, and basically those numbers there are z-scores. That's the number of standard deviations you're away from the mean. And all the numbers, even though they're really different, look how similar they look, right? Now they're all kind of in the same -2, well, I mean, standard deviation is usually between -4 and 4, like at 99%. Definitely between -8 and 8. And they're all really close. So now when you get your weights, it's that they're not going to be crazy off. So this is all kind of like, I don't know. I mean, first time I did it, just kind of the paradigm shift I had was crazy. All right, so you can stop sharing. Let me share one thing because I do want to show you this. Really cool.
Thank you, Damien.
Damien, you're awesome, bud. You rocked it.
Great job, Damien.
I'm just trying to keep up.
Well,
Great.
Warp speed.
So, you know, I've just found that when I do it, I go too fast. And then I don't see the errors that other people are making.
Well, I'm glad I could be of service.
Yeah, so no, you didn't make that many errors. So you actually kind of flew. So I know we got to go.
Errors are good. You can certainly see how being able to do this, now suddenly you have this ability to manipulate these huge collections of numbers by adding features in, weeding features out, modifying, looking for trends. It's pretty impressive.
It's really cool. And so I use Spider, which I put some links if you wanted to download and install, which I know your students can't. The nice thing about Colab notebooks is your students could run it with anything because it doesn't even run on their computer, right? It runs on Google servers. So the cool thing though, and hopefully you're seeing this, let me pull this over.
Mm-hmm.
The cool thing with Spider is the variable explorer. This variable explorer is amazing. It tells you, you never have to print anything. You just, you run it and it shows you, it even color codes. So the smaller the numbers is a different color. It's really, really cool, especially for NumPy arrays. So I really, this is so, all right, so let's do a summary real quick with where we were at. Actually, I don't want to close this, cancel. Let me get to where we're at. And I'm kind of glad, it's not the one I want. Kind of glad that it's not what we want. We want Zoom 5. There we go. Okay, so what we went through, and I'm going to I will put the link for the solution out there. Here's shortly here. It's not as pretty. It's not as pretty, but that way for other people, if they struggle and they're trying to do it on their own, but we kind of went through everything anyway. So the link out there. I also did a Matplotlib. There's a Matplotlib cheat sheet, but if you just follow this PowerPoint and copy and paste the code, it gives you all the code to do some basic graphing. These are some other cheat sheets. Then if you wanted to download Anaconda and install Spider, this tells you how to do it. There's actually a video that walks you through it and actually gives you, this is a link to the exe if you wanted it. And then I was thinking, well, we didn't have time to do this, but you can actually read in data sets and plot them, which is cool.
Wow. And Anaconda is like pip, that's like an installer?
Yeah, so Anaconda does your pip for you. Okay, so it says, oh, you have version blah, blah of this. Well, I'm going to automatically make sure all the other stuff you're using has the right version, and it does it all. Yeah, it's the automatic pip thing. So you don't ever do pip. Don't ever do pip. And Anaconda, I don't know if you've ever seen it, but Anaconda, you can create environments. Then when you're doing stuff, this is crazy, right? Then when you're doing stuff, it makes sure all these versions over here on the right-hand side, you know, if you're using version 3 point whatever of Python, it makes sure, you know, Matplotlib is the right version. It makes sure everything else is the right version. And you also get a free Spider, which is a nice, I like the IDE. I know, you know, for me, it's nice. You get the Jupyter Notebook. Orange is cool, but we make the kids, because our kids can install their own software, and we make them do Anaconda, and we just go from there.
What grade level do you teach?
Huh?
What grade level do you teach?
Okay, so juniors take the machine learning. They take APCSA sophomore year. And we have a whole 4-year kind of pathway. So the kids take like intro to CS freshman year, and then senior year, they do their own thing. They have a research lab thing where they create something on their own.
So this is a post-AP data mining course or data?
Machine learning. No, they do. We make them calculate backprop by hand. They do Keras. They do a lot. They do supervised and unsupervised.
Damien, I'll send you John shared the syllabus with all the resources and what he covers in the 2 courses. It's 2 semester courses, right, John?
Yeah, it's down here.
Oh, it's on this document too? Okay, super.
I think so. That's the high level syllabus. I don't think that's the link to like my.
Because you had shared the other one with us before.
Yeah.
So where do you go? Where did you go to learn all this? Crazy. This is amazing.
Sucked. I went to Andrew Ng. I went to CS 300 from Stanford. Sucked. It sucked. And luckily there's another teacher that teaches with me. So the first year was not a lot of fun. There's not a whole lot. There's stuff out there for 300 level college people, but there's nothing out there for high school students. You gotta take it and boil it down. Yeah.
Yep. That's what you got to do.
One of the challenges for teachers, and I will absolutely take responsibility for this and speak for myself, but it's like trying to get into Java and trying to learn the latest and greatest things. It's like, by the time I am up and saying, oh, okay, yeah, I need to learn this pip thing to do all this installation. Pip is gone. Now we're on to Anaconda. Now we're on to the next thing. And Jupyter Notebooks. Someone told me a few years ago that I should really check that out. But now we're moving past that. So everything in the Python world is cycling so quickly.
Oh my God.
How do I come up with a curriculum when I can barely keep ahead of it myself?
Well, we're just giving kids the foundation, right? We're not trying to ready professionally. We just got to give them this base. And yeah, when things change, like John said, you're setting up to learn how to learn, right?
Yeah.
You make them go find the answers and go find, oh, that changed. What is it now?
But honestly, broadcasting last year, I mean, it was middle of year 2 when we're like, broadcasting, what's that? I didn't know what it was.
So you had to have other.
And I think it came out like 3 years ago or something. So I don't know when it came out, but I didn't know what it was. I mean, there's this stuff and you're just like, and now I just gave it to you. I just gave you broadcasting. It took us like 3 weeks to figure out when the heck that is, but yeah. So anyway, hopefully this kind of whetted your appetite.
Absolutely. This is pretty amazing. Thank you.
Oh, you're welcome.
Really appreciate it.
Yeah.
All of you.
Yeah.